Stay up late though it rains. It's good, but it is never the same. Never really the same.
Hello and welcome to the concepts video on inverses and radical functions. So I'm going to start off by saying the following statement. So the inverse of a quadratic, okay, so i.e. Of the form x squared of some sort, is a square root function. Square root function. So of the form, something like that, where you have like something in there, okay? And now let's see why, okay? So let's start with an example. Okay, so we're given this equation here, and we're supposed to find the inverse of it. So in order to find the inverse, this is the process we're going to go through. So process is the following. So we just write our f of x is equal to some function, right? We're going to write it as y is equal to whatever we have, whatever we're given as the equation for our function. Okay, so something like that. And then we just solve for x. And that's it. Once we get x by itself, that gives us the formula for our inverse function. Okay, so once we solve for x, then we get f inverse of y, which is the same thing as the inverse of whatever we started with. Okay, so let's try to put this, so we have this formula here, okay, that I just put in. Okay, I just replaced our f of x with a y, and what we want to do is solve for x. So here it's not exactly clear how we're going to solve for x, so one suggestion is going to be to put this thing, which is currently in standard form, put it in vertex form first. Vertex form. And just a reminder, vertex form is when you have a constant times x minus h squared plus k, where hk is your vertex. Okay, so let's just find the vertex from here. And the way we can do that is saying that h is equal to negative b over 2a, where b and a and c come from your standard form, right, which is perfect. So we're going to have negative 4 over 2a, and a is a 1. It's like the coefficient in front of your x squared. So this is going to become, so the negatives cancel out, and we just get h is equal to 2. So that's pretty simple. And then we just find our k by plugging in our h into the function. So f of 2 is going to be equal to a 2 squared minus 4 times 2 plus a 1. So this is equal to negative 3. Okay, so we found our hk, 2 comma negative 3. This is our vertex. And then we don't have, well, our coefficient in front of our x squared is just a 1. So that means we can write our vertex form. So a is equal to 1, and our vertex form gives us y is equal to, so 1 times x minus whatever h is, so 2, and then squared, and then plus k, so plus a negative 3 means just minus 3. Okay? So this is where we're at right now. I just transformed this equation here into vertex form. Okay? So we can work with it a little bit more easily. Okay? So let's continue this on the next slide. So we have y is equal to x minus 2 quantity squared minus 3, and what we're aiming for is solving for x. Okay, so we're just going to solve for x. So this is a little bit more workable, right? Because we can add 3, we can switch some things around. So we have y plus 3 is equal to x minus 2 squared. So now to get rid of this squared power, we just square root, right? And that sounds easy, but and I mean it is in a way. So on the right side, we just get x minus 2. But the thing is, when you square root something, we always get a plus or minus, okay? Because whatever we had before could have been plus or minus, and then when you square it, you just get positive anyway, so it doesn't really matter. But when you go backwards and you square root something, then that kind of introduces this ambiguity, like uncertainty on whether it's plus or minus, okay? So from here, what we're going to do is just continue solving for x. So plus 2 plus 2. So we have x is ultimately equal to 2 plus or minus the square root of y plus 3. Okay, so why does this happen? Let's examine graphically what happens here, okay? So let's say we have something like this, and we have our x and our y. And before, remember our vertex, which we found, it was at 2 comma negative 3, right? So we had 2 comma negative 3, something like this, okay? I'm just going to graph some stuff here. So, and then we just had a normal, there's no stretching or anything, so it looked like this. This is our parabola that we started with. This was our f of x, okay? Alrighty, so when we flipped everything, when we swapped everything, and found the inverse, then we get something like this, where we have, let me see here. What is it? It looks something to this effect, okay? And it's flipped about this y equals x line. Anyway, so we get something that looks like this, which is not exactly right, because do you see how this is the resultant f negative 1 of y, which this is, I should have put here. So this is equal to our f negative 1 of y, which is the inverse, okay? So we found our inverse, but the thing is, we can't have this plus or minus sign, because that gives us both pieces of the curve here. Okay, and we can't have that because it doesn't pass the vertical line test, which means it's not a function. So what we're really going to have to do is kind of just cut it in half, kind of thing. Well, see how if I were to draw a line here and just kind of, I don't know, just ignore this part of the graph down here, we would have a function. It looks like a square root, right? So in doing so, that would just mean that we want our x here, or our inverse function, to only have values of 2 or higher, okay? So that would mean our negative would go away. That gets rid of that negative sign and the ambiguity, so we just get one solution, which looks like this. Like that right there, okay? So that would give us just this upper part of the graph, which would be perfect, right? And this is the same thing as limiting your domain, or restricting our domain. Okay, this is the same thing as saying that, okay, from our original function that we had here, our f of x, this u down here, that's the same thing as saying, okay, we only want our x to be greater than 0. Or, sorry, not greater than 0, greater than 2, right? Because here's the line, that line I was drawing is x equals 2. So this is where we're at here. So if we want that to be greater than 2, we would just get this right half of the parabola, right? The one I'm shading in here. We wouldn't get this side at all, okay? So when you do flip it and we kind of transfer it to the inverse, then that gives us a function too, okay? Now we have this one-to-one function which can go back and forth between inverses because we restricted our domain to be x is greater than or equal to 2, okay? I know it's a little bit tricky, kind of a lot bit tricky, but anyways, that's basically what we're doing, is restricting our domain, meaning that we only want to pick one of these signs here. We don't want both of them to exist because that means we don't have a one-to-one function, which means it can't have an inverse, right? Okay, so anyways, so keynotes to take away from this are the following. So I'll just write keynotes. Okay, so the first thing is going to be that when you find the inverse, so when finding, I'll do a little bit of writing here for you guys. So when finding inverse, if I can spell, of a quadratic, and again, quadratic just means anything squared, something with a squared thing in it, we must, as shown by the last example, limit or restrict ourselves to a domain meaning what can your inputs, what are they allowed to be, okay, on which our function, our original function that is 1-to-1, okay? So remember 1-to-1 means it passes the vertical line test, because it has to be a function first of all, and it passes the horizontal line test, okay? So that's really important. Number 2, the second important thing I want to note is just that the inverse of a quadratic, and I've already stated this in the beginning, but we just saw how inverse of a quadratic, meaning something squared, is a square root function of some sort, okay? Alrighty, so sometimes determining the domain can be a little bit more complicated than what we just saw, okay? And let's do an example of that. Okay, so for this question, we're supposed to find the domain of our function. F of x is equal to the square root of all of this stuff. So the domain for this one is going to be, well, anything inside of a square root has to be greater than or equal to 0. So we can just set everything inside greater than or equal to 0 and solve for the intervals on which this is true, okay? And then that will be our domain. So when we have something like that, we just have inside, all of that stuff I circled, greater than or equal to 0, okay? And then what we're going to do is consider, this is kind of like a polynomial inequality, but in this sense, this is going to be a rational function inequality, right? Because we have a ratio of two polynomials. So anyways, we're just going to consider the equality part of it, okay? And then this is going to be, it'll give us equals 0. Okay, so this occurs, we could have a possible sign change of our function. So possible sign change, when we have a vertical asymptote or a horizontal intercept. Okay, so basically when the top equals 0 or the bottom equals 0. So basically we're just considering all of the possibilities on which things can be 0 in this fraction here, or in this ratio. So x equals 1, that would be a vertical asymptote. How about x equals positive 2 and x equals positive 3? Okay, so, oh, actually this is a, sorry about that, sign difference here, I copied that. So that's an x plus 2 up here. So we're actually going to get x equals negative 2 or positive 3, okay, for the horizontal intercepts there. Alright, so at this point, we can kind of just do our sign analysis, remember? So we're just going to put these, I call them critical points, on a number line. So we have negative 2, we have positive 1, we have positive 3. We're just going to pick our test points, okay? So we can pick negative 3 as a test point. How about 0? That's a fun one. 2, and we'll pick 4. Okay, so we're going to plug each of these test points into this expression here, okay, and see if it's positive or negative. So first of all, we have negative 3 plus 2 times negative 3 minus 3 over negative 3 minus 1. So if we just look at the signs, we have negative times another negative, and then over another negative. So this is 3 negatives all in one, so that just makes it negative. So we have this interval is negative, so that's definitely not going to be in it, right? Because we see that it's not greater than or equal to 0 on this interval up to negative 2. How about the next interval? So let's try 0. 0 plus 2 times 0 minus 3 over 0 minus 1. Okay, so we have a positive times a negative over a negative. That's perfectly fine, and we get a positive. Okay, so this is a positive interval. So this one will be included in some way, shape, or form. Okay, so that interval there. Let's test the other two test points on the next slide. So then we have, let me just rewrite our expression here. So then x minus a 3, and then x minus 1. So we're trying to determine when this is greater than or equal to 0. So, so far we have this negative 2, 1, and 3. We're testing 4. We're going to test 2, so those are the ones we have remaining, and we already determined that this one is not in it because it's negative. This one's in it because it's positive. Now we just need to test the other ones. So we have 2 plus 2 times 2 minus 3 over 2 minus 1. So this is going to be a positive times a negative over a positive, so that'll be negative overall. Okay, so this is negative, so that's not going to be in it. How about let's test 4? So then we have 4 plus 2 times 4 minus 3 over 4 minus 1. So this is definitely going to be a positive, okay? So both of these intervals are included, the ones that I'm boxing right now. So this would just be, and it says greater than or equal to, so we can include the actual 0 values, so negative 2, negative 1, and this 3 here. So our intervals are going to look like the following. So we have negative 2, comma, and then 1 is actually not included. Because, and why is that? Because when x equals 1, we have that vertical asymptote, at which our function is undefined, so we can't include the 1. So we just put the round bracket. That's fine. So we have that interval. That's all taken care of. And then we have in union with, just means like also, in addition to this 3 to infinity. Okay? So this is the domain of our given function. Alrighty, so we can also find inverses of rational functions, okay? So inverses of rational functions. Rational functions, especially those that are ratios of linear functions. Those are pretty much the easiest or the simplest that we'll run into of linear functions. And what do I mean by that? Let's do an example of one of these problems. Okay, so we're going to find the inverse of c of n is equal to 20 plus 0.4n over 100 plus n. So what we really want to find, so the inverse will be denoted by n inverse of c. So basically what we want to do is just solve for n in this case and get n by itself. So if we write it out as c is equal to 20 plus 0.4 n over 100 plus n, what we can do first is just multiply it by this on both sides to get it out of the denominator here. So 100 plus n, then we multiply by, so times 100 plus n, okay? So on the left side we get c times 100 plus n is equal to, these ones cancel out, and we get 0.4n, I'm just going to switch the order real quick, plus 20. Okay? Alright, now we're just going to distribute this c in. Okay, so we get c times 100 plus c times n is equal to 0.4n plus 20. And again, we're aiming for getting n by itself. Okay? So what we can do is now just subtract, I guess we could do. So let's say we subtract cn from both sides, subtract cn, okay? And then we could also subtract 20 at the same time, minus 20. So on the left side, we get c, or I'll just put 100c, and then minus a 20 here, is equal to 0.4n minus cn, okay? And let's continue this on the next slide. So we have 100c minus 20 is equal to 0.4n minus cn. On the right side, we can factor out an n, okay? So n times 0.4 minus c, alrighty? And then kind of ignoring this middle step in there, we're just going to divide by 0.4 minus c, divide by 0.4 minus c, and voila, we have n by itself on the right side, okay? So we get 100c minus 20 over 0.4 minus c, okay? And this just gives you your n inverse of c. So this is our inverse function. Alright, so that does it for our concepts video on inverses and radical functions. I hope that helps, and I'll talk to you in the practice problems video if you watch.